The world that leaders are operating in today, it's just fundamentally unrecognizable from what, even 10 years
Oh,
ago.
not even. The whole different ballgame.
We are talking about environments defined by, not just complexity, but this unprecedented speed, this velocity of data, and just the sheer scale of everything.
Exactly. Think about it. You're orchestrating global supply chains that are being disrupted, you know, constantly
Yeah.
by geopolitics.
Right. Or you're trying to figure out how to deploy something as revolutionary as generative AI and do it ethically and profitably.
hmm And at the same time, you're trying to understand your customers across 1,000 different digital touch points. It's overwhelming.
It is. And that's why the traditional leadership toolkit, the skills we've always focused on, charisma, vision, managing stakeholders,
The interpersonal stuff.
the interpersonal stuff, it's all necessary, yes, but it's proving profoundly insufficient for actually designing and running the systems that govern this new reality.
That's the key word. Systems.
So, our mission in this deep dive is to unpack the one critical cognitive skill that really bridges this massive gap: computational thinking, or CT. We've got sources showing why a staggering 87% of executives say this skill is absolutely essential for their future, and yet, get this, only 23% feel genuinely confident using it.
It's a huge chasm.
It is. So we're going to break down what CT actually is, how the best organizations are building it, and why this is, I think, the defining career imperative for you right now.
And we absolutely have to start with a foundational clarity check, because that term, computational thinking, it just carries so much baggage.
It's going to hear computer.
Right. It gets immediately confused with coding or, the idea that you suddenly need to become a data scientist. And that is precisely what it is not.
So what is it?
Well, what's fascinating here is that CT, as it was first talked about by Seymour Papert way back in the 80s, and then popularized by Jeanette Wing in the mid-2000s, it's fundamentally a structured cognitive toolkit. It's for problem solving.
A toolkit. I like that.
It's the mental process of formulating problems so effectively that the solution can be represented as a series of steps, as a robust algorithm. It's disciplined thought that's designed to scale.
So if it isn't coding, and it's more than just, general critical thinking, how is it different from the standard analysis that managers do every day?
That is the core distinction. Traditional analytical thinking, which is what most leaders are trained in, it focuses really heavily on the outcome.
Getting the right answer.
Getting the right answer case by case. Computational thinking, though, it emphasizes the process. You're designing a systematic approach that can be automated, that can be scaled, and can be improved over time.
So you're not just solving this problem.
Exactly. You are building a flexible machine to solve all problems of this type.
Okay, let's unpack that. Let's dive into the nuts and bolts, the 4 pillars that really define how a leader with this skill approaches a challenge.
Let's do it.
The first pillar is decomposition. This is the art of breaking one massive, complex problem down into a series of smaller, more manageable subproblems. It sounds simple, but
the distinction is key. When a manager delegates, they break a task into subtasks. That's one thing.
right.
When a leader using CT decomposes, they break a system down into its constituent elements. Elements that are algorithmically solvable, or at least measurable with their own distinct metrics.
Give us an example.
Okay, take a big strategic challenge like improving customer retention. A traditional leader might launch a general campaign.
A loyalty program or something.
Right. But a CT leader decomposes the process. They look at, say, acquisition quality, that's pillar A, then onboarding friction points, pillar B, then service recovery protocols, pillar C, and so on. Each of those is now a distinct, measurable system you can optimize.
And that clarity, that structure, it leads right into the second pillar, pattern recognition. This is all about identifying similarities or, regularities across different contexts, so you're not constantly reinventing the wheel.
Exactly. A computationally literate executive doesn't just solve a supplier issue in, say, the Asia region. They immediately ask, what's the underlying logic error here? What's the common pattern that allowed this to happen?
And where else is this happening?
Where else is that exact same pattern playing out in our business? They use that pattern to anticipate challenges, maybe in Europe or North America, and transfer the solution. The whole organization gets smarter from one fix.
Okay, pillar 3 is abstraction. And this feels, this is so crucial in today's data-drenched world.
Absolutely. Drowning in it.
Abstraction means filtering out all the irrelevant details, all the overwhelming noise, to focus intensely only on the essential features, the signal.
If you've ever sat in a meeting with a chart that has 50 variables on it.
And no one can agree on what matters.
Yes.
The cost of poor abstraction. A leader applying this pillar might build a simplified model, that captures just the 3 or 4 key dynamics of their market.
And that's how you communicate complex ideas clearly, through these concise frameworks that everyone can actually grasp and act on.
Which brings us to the final pillar, algorithm design. This is the synthesis step, right? Where you create the systematic step-by-step procedure to solve the problem.
That's it. You've decomposed it, you've found the patterns, you've abstracted the core principles, now you build the process. In leadership, this translates directly to developing robust, documented, systematic processes for decision-making.
So standardizing best practices.
Yes, the most effective way to onboard a new employee or handle a compliance review or triage a product bug, you are designing a repeatable workflow that gives you consistent, predictable outcomes. It minimizes the reliance on just, one person's heroic intuition.
Okay, so we have the framework. We know it's the engine of modern scalability. But let's go back to that shocking survey finding. 87% of leaders say this is vital, but only 23% feel confident. That is a massive chasm.
It is. And the data suggests that gap is most pronounced among senior leaders who really established their careers before the big digital shift, let's say the pre-1990 cohort.
So they got to the top using the old toolkit.
They did, and they were very successful with it. But now they're leading organizations that run on a completely different computationally driven infrastructure.
So why does this deficit persist? I mean, why haven't these smart, high-performing executives just picked this up along the way?
Well, part of it is just organizational inertia. Traditional executive education.
Yeah.
It was all built around case studies, strategy, finance, HR. It was all historical, situational reasoning.
It taught you what happened.
Right. It taught what happened, not how to design the system that would consistently produce the optimal outcome.
And specialization is a barrier, too, I'd imagine.
A huge barrier. You spend 20 years rising through marketing. You develop deep domain knowledge, great heuristics. But you might lack the cross-disciplinary skills to really talk to your tech teams or think systematically about IT architecture.
Plus, the culture often rewards quick, decisive action.
It absolutely does. And that actively discourages the upfront, sometimes slower, effort required for systematic decomposition. When you're under pressure, you default to those quick guesses, not the rigorous computational approach.
And the cost of relying on those guesses is, well, it's measurable and it's severe. Let's start with digital transformation failure. The research shows projects led by executives who are fluent in CT achieve success rates 2.6 times higher. 2.6.
That's a staggering difference.
And conversely, you look at the systemic failure rate, there's a well-known McKinsey finding that only 8% of organizations successfully scale their digital and analytics initiatives beyond the pilot stage. Just 8%.
And our sources pin that failure directly on this thinking deficit at the top. The tech works. The leadership just can't computationally decompose the change challenge itself. They can't design the new workflows to actually embed the technology.
Another huge consequence is data underutilization.
Oh, this one is massive. Analytics failure. Organizations are investing billions in data infrastructure, yet studies consistently show that somewhere between 60 and 73% of enterprise data goes completely unused.
It just sits there.
It just sits in storage. And this happens because leadership isn't thinking computationally about embedding data insights into their operational processes. They can pull data for a one-off decision. Should we launch product X?
An ad hoc request.
An ad hoc request. But they struggle to model the actual process steps where data consumption should happen automatically, consistently. If you can't design that algorithmic flow, the data just remains a luxury. It never becomes a necessity.
And then there's the cost to innovation, which is palpable. The evidence is so clear. Organizations where leaders think this way generate 40% more patent applications, and they bring products to market 35% faster.
It streamlines the entire R&D process, which is famously chaotic. They know how to systematically test, iterate, and decompose these really complex research challenges.
And even outside of R&D, just in pure efficiency.
The gains are undeniable. Take manufacturing. Facilities led by managers who are computationally literate achieved 18% higher productivity.
18%. Why?
Because they systematically optimize workflows. They decompose machine problems into solvable algorithms. They standardize best practices across all the shifts. They minimize the human variability that creates errors and slows things down.
And we absolutely have to connect this back to people, to employees, and to the customer.
Yes.
When leaders fail to design systematic workflows, the ripple effects are clear. Employees report 28% lower job satisfaction, increased role ambiguity. Their work environment just feels chaotic and poorly structured.
And for customers, that inconsistency is poison.
Yeah.
The research shows that an inconsistent customer experience driven by a lack of an algorithmic approach to service actually drives churn more strongly than the average quality of the experience.
So it's the variability that pushes people away.
Exactly. The computational mindset is about designing the process that produces a guaranteed, consistent, high-quality outcome every single time.
Okay, so the evidence is just overwhelming. CT is vital. The gap is dangerous. So, the million-dollar question, how do organizations actually fix this? Let's turn to the specific evidence-backed interventions.
The first one, and it's probably the most accessible, is structured decomposition training. This isn't about teaching Python. It's teaching leaders systematic problem structuring. Tools like issue trees and logic trees.
Wait, can you define those really quickly? What's an issue tree here?
Sure. An issue tree is basically a visual framework. It forces you to break a high-level question down into all of its mutually exclusive and collectively exhaustive components.
So you don't miss anything.
You can't.
Yeah.
You can't solve the problem if you haven't mapped the entire territory first. Procter & Gamble is a great example. They embedded this training, teaching executives how to break down these big, vague questions like, how do we accelerate growth, into specific testable hypotheses.
So they went from brainstorming to decomposing.
Precisely. And internal assessments found that business units, led by these trained executives, achieved a 16% faster problem resolution time, just because they knew how to structure the problem correctly from day one.
Okay, intervention number 2 is really powerful. It's experiential, cross-functional immersion. This means placing executives into engineering or data science teams, not for a meeting, but for multi-week rotations.
Capital One pioneered this. They require their senior leaders to do these immersion programs. It even includes things like pair programming with software engineers.
They're not actually writing code, are they?
No, they're not expected to write production code. The goal is for them to internalize the engineering mindset. And leaders who finished this reported a 34% improvement in their ability to have a real, substantive, technical conversation. They shifted from just requesting outcomes to actually modeling processes.
The next one is algorithmic literacy and process modeling.
Right. This is training that teaches leaders to map their current workflows and then redesign them using those fundamental algorithmic principles: sequence, selection, and iteration.
Okay, let's unpack that jargon for a second. What do those 3 mean when you're talking about a business process?
Absolutely. Think of them as the 3 basic building blocks. Sequence is just the ordered steps. Do A, then B, then C.
Simple enough.
Selection is the conditional logic. If the input is X, then you follow path 1, ELSC, you follow path 2. And iteration is just repetition. Repeat step D until some condition is met. Training leaders to see their business through this lens, it teaches them how to design for consistency.
And this works in the real world.
The Cleveland Clinic implemented this for their clinical and administrative leaders. They mapped complex patient care pathways using these principles, and by designing standardized algorithmic protocols, they got a 23% reduction in care pathway variability, a 19% improvement in patient flow, all through disciplined process design.
So a 4th intervention focuses on data-driven decision frameworks. This is basically institutionalizing systematic experimentation.
This is CT applied directly to strategy.
And Booking.com is the masterclass here. They are famously designed around this. They run over 1,000 simultaneous A/B tests at any given moment.
They don't debate intuition in a boardroom. They train leaders to formulate testable hypotheses, and then they institutionalize what works, what's proven by data. It's a purely computational approach to optimizing the entire business model.
And the final one we have is systems thinking and modeling.
This is teaching leaders how to abstract and model really complex systems, identifying feedback loops, nonlinearities, all of that. It helps you anticipate the unintended consequences that can just derail so many big projects.
Shell uses this, right?
They use it heavily in their scenario planning. Instead of linear forecasting, they model dynamic possibilities. And the research shows that their business units, led by executives with strong systems thinking skills, achieve 27% higher strategic forecast accuracy. They're just better at modeling complexity.
What's so crucial here, though, is that this can't be a one-off seminar. It has to become part of the organization's DNA.
It has to be a structural change. It means integrating CT proficiency into how you assess leaders, creating mandatory rotational assignments in process improvement or analytics teams. You have to make the practice part of the job.
Amazon is really the perfect case study here. They've built these organizational mechanisms that just force computational thinking. For instance, their famous narrative memo format instead of a PowerPoint.
It forces decomposition and abstraction. You have to write a complete structured argument before you can even start the work.
And their working backwards process is brilliant. Before they design a product, the team has to write the final customer press release.
And the FAQ document.
Right. And that requires you to algorithmically specify the entire desired customer experience step by step. The system itself enforces the thinking.
And this has to be reinforced by the culture. You need senior executives visibly modeling this behavior, explicitly talking about how they're decomposing problems. And critically, the organization has to have a failure tolerance for systematic experiments.
Meaning you have to let people test things and be wrong sometimes.
Exactly. You have to allow leaders to test hypotheses and learn from the results without fear of punishment.
Yeah.
If you penalize learning, you kill computational thought at its root.
So to bring this all back to you, the listener, this is your immediate career imperative. The data is just unambiguous. Leaders who lack these CT skills, they will struggle to communicate with their technical teams.
They won't be able to extract true scalable value from these massive digital investments.
And at the end of the day, they're just ill-equipped to design the systematic, predictable processes that define a high-performing modern organization.
This isn't a soft skill anymore. It's a hard requirement for executive function. The evidence is robust now. Organizations have to act decisively to build this capacity, integrating it into their curriculum, their culture, everything. It's how you navigate the complexity of our age.
And computational thinking can be learned. It can be learned at any career stage through deliberate practice and systematic reflection. So if you are not explicitly working every single day to improve your problem decomposition, your abstraction filtering, and your algorithmic reasoning, ask yourself this. What is the cumulative cost of those unscaled, inconsistent, intuition-based decisions you made just last week? That unaddressed inconsistency, that failure to design a scalable system, that is the new, unacceptable cost of relying on intuition alone.